Before we go on to the third step where we create our circuit, I just want to do another problem or two with the truth table and the equation just to make sure that we think we've got it. And then even after we do all three, I'll probably do another couple of videos that just review the whole process a couple more times. So let's just do another problem. We did adding in the last problem, so let's do an easier problem. It may surprise you, but multiplying is easier than creating a circuit for adding, and I'll explain why. So let's kind of go through the steps we're going to do each time we do a truth table. So this is step one, a truth table. We're going to determine how many inputs and how many output bits. We're going to multiply two 1-bit numbers. Now, last time we added two 1-bit numbers, and let me just write up to the side here, and this is fine if you need to write out, all the possibilities, go right ahead. We could have 0 times 0, 0 times 1, 1 times 0, and 1 times 1. So there's our four types of math problems that we could do by multiplying two 1-bit numbers. Does that make sense? So four separate problems with only 1 bit. Obviously, if we had 2 bits, we could do bigger numbers, but with 1 bit, that's it. Now, let's write the answers. 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. Remember, the computer does not understand what we mean to multiply until we have taught it what multiplication is and what the answers will be. So in this case, we're going to teach the computer the answer. So I'm going to rewrite all the input numbers up here. So we have a 0 and a 0, a 0 and a 1 and a 0, and a 1 and a 1. That corresponds to four types of problems. Now, before we had a C and an S up here for carry and sum, because we needed 2 bits. In certain additions require 2 bits. Well, over here, notice, no matter what problem I do, I only need 1 bit. 1 bit will always hold the answer. There is no 2-bit answers. So I'm just going to make a single letter P for product. And then we can just teach the computer, whenever 0 times 0 is the math problem, I want the answer to be 0. Whenever 0 times 1 is the math problem, I want the answer to still be 0. Whenever 1 times 0 is the problem, 0 again. And when 1 times 1 is the problem, 1. Now, maybe, and hopefully you can see already why I said multiplication is actually a much easier problem than adding, and here's why. Well, number one, there's only one equation. So let's go on to step 2 here. Let's build our equation here. There's always going to be one equation for every output bit. Well, there's only one, so P equals, and that's it. There's not going to be any other letters. The other reason it's easier is because I said if there's a 0 here, we don't care. We skip over it. Skip over it. Skip over it. We finally have a 1. Look over here, and if there's any zeros, we have to put lines over them, meaning not, but we don't. It's just x and y. So, and just to review our Boolean logic, x and is how you would say this, y. P equals x and y. That's it. That's all step 2 is, because multiplication is an easier problem. I hope that makes sense. Hopefully I explained that. Okay. I want to do another problem. I'm trying to remember if there's anything else I want to say before I do another problem. But let's just do one more problem. I think the best thing is just to see multiple examples of this. So let's create another problem. Let's say step 1, create a truth table. We're going to subtract two 1-bit numbers. Okay, so let's write it out first. I mean, you could go straight to the table if you wanted, but sometimes it's easier to come up with a kind of a shortcut. So we could say 0 minus 0, 0 minus 1, 1 minus 0, and 1 minus 1. Now, have you noticed that every time we do two 1-bit numbers, these are the four options? Now, maybe there's a subtraction versus a multiplication, but it's the same four numbers, which means these will always be the same four if you're ever doing two 1-bit numbers. Now, in a moment, we're going to do three 1-bit numbers, and that means there's going to be an extra column over here. Let's do some math now. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 1 is negative 1. And 0 minus 0 is 0. Now we have a little bit of a problem here because for the first time we have a negative sign. So let's ignore that for now, and let's just look at, I'm going to use, let's see, x and y again, and I'll use s for subtract. What is the answers here? We have 0 minus 0 was 0. 0 minus 1 is negative 1, but we'll come back to that negative in a moment. 1 minus 0 is 1, and 1 minus 1 is 0. Now we have this negative sign here, so what we're going to do is we're going to actually have an output that's basically saying, is this number negative or not? Okay, so we're going to have, no it's not, yes it is, no it's not, no it's not. Does that kind of make sense? So only one of these was negative. So if you read this, that's positive 0, negative 1, positive 1, and then 0 again. Okay, so now let's make our equation. Okay, and you're going to see why we need an equation, because it makes creating the circuit in step 3 much easier if you already have it. You could technically go straight from 1 to 3, but this makes it much simpler. So we're going to have, remember, you have one letter for every output. Let's do the easy one first. Don't care. We do care. X and Y, but we have a line over the X, and then we don't care, don't care. Let's come up to S. S is equal to, in other words, I want S to be 1, not here, but here, so we have the same thing. Or, whoops, go away. Or, remember, the plus sign means or. That means we can have a 1 in more than one scenario. Here's one scenario. This row is a scenario, but this is also a row where I could have a 1 in the S column. So it's X and Y again, but this time the Y has a line over it. And then we don't care. So these two don't care. So that's another example of a step 1 truth table and a step 2 equation. And hopefully by now you kind of get, like I said in the first video, it'd be great if you understood that this meant I want S to be true when X is 0 and Y is 1, or when X is 1 and Y is 0, because when this is 0 and that's 1, but the X gets flipped to a 1 with that line, that turns that into a 1. And as we learn, 1 and 1 equals 1. And over here, X, when Y is a 0, but the 0 gets flipped to a 1. So when X is 1 and Y is 1, 1 and 1 is equal to 1. So, and 1 or 1, remember there's an or connecting, is also equal to 1. So just remember the steps if you have to just memorize how to do the steps. And the next video we're going to finally get to, I think, is the fun parts, the more visual part of the process, and that is creating a circuit.